Yep, elimination and substitution as methods to arrive to what exactly?
Your x and y. Well, your
What did that represent?
the linear system.
Or substitution, yeah, but what was that xy coordinate for?
Oh, the point of intersection.
The point of intersection, right? So that's what that represented, a point of intersection, and we're doing that through elimination or substitution, right? Now, we're not going to revise all of them, but what was the main step in substitution? What were we doing there? If I have there an x plus 2y is 12, and a 3x plus 4y is negative 2. I'm going to focus on substitution. What would I need to do? Isolate for x, y, or make everything equal to 0. What's the general strategy to substitute? Sorry? Isolate for one of the variables, right? Either x or y. So let's say y in this case. So from the first one, if I isolate for y, I'm going to get 12 minus x all over 2. For the second one, if I isolate for y, a little more complicated, we have a negative 3x minus 2 all over 4. Okay, so once we solve for this, we usually go 12 minus x over 2 is negative 3x minus 2 all over 4, right? And that's now an equation that I can solve for x, and then I can go back to either 1 or 2 to solve for my y, right? So at the point of intersection, I will always have the x and y coordinates equal to each other, right? So the x from equation 1 should be equal to the x of equation 2, and same for y of equation 1 should be equal to y of equation 2. That's not a formula, it's just what happens graphically, right? You don't really need this graph, but just to remind ourselves, any two lines, so in this case, I have a negative slope. It doesn't really matter how I draw it. And then let's say another one. Oops. And I notice here at the point of intersection that the x and y are shared, right? By the two lines, okay? So that means I can do the same thing with a line and a parabola, right? I can replace one of these lines. Do you still need some time? That was just review of linears, right? So any two lines I solve through substitution, I can get the point of intersection. Now, if I replace a line, let's say with a parabola, what do you think the solutions will be? So in this case, quadratic function. I'm going to do this graphically first, just so we can get a better picture of what's going on. So I'm literally just replacing one of the lines with a parabola. I'm going to use the same line in all of these. So let's say this is my f of x. I don't really care what it's equal to. It's something like mx plus b, right? And like I said, I'm going to keep the same one. And we'll have a couple of scenarios. And I'll let you talk to your partner about what these might be. So if I have that line fixed, what are the scenarios for a parabola? You can talk, chat with somebody. Maybe Isabella, Matilda, Kirsten. Adele, you can move to the front. 2 minutes. No, not chat with the paper. Chat with somebody. I have to add a parabola. I haven't added a parabola in yet. Sorry? We're just looking at linear quadratic systems. So before we're doing linear. But now I'm trying to figure out how I can get to the solutions.
But you need to draw that 3 times.
There will be different scenarios, yeah. So where am I going to place that? Excellent work. That's not quite a parabola, but...
Good job, Daddy.
Okay, and girls, the last one. Girls? What?
I'm doing a group. I didn't do one yet, but I know what it is.
There's one more case.
What? I'm trying to group. Oh, sure. I thought I should participate. No. Okay, the brother thing. It touches it one time. One time. There you go.
Okay. Yay. Excellent. Good effort, everybody. Again, that's not quite a parabola, but good enough. Okay. Okay, so because you guys went negative, all of you went with a negative, I'm going to go with a positive, okay, just for some balance. So again, we have two, this could be two solutions. So let's say this one here. I'm showing two. Okay. So we have two solutions for the linear quadratic system, right? And let's say the one solution case, in this case it will touch at one point. Okay, so that would be one solution. And the no solution case, which in your case is below the line. In this case it will be above the line. So whichever one you decide for, it's fine. So 0 solutions. Okay, or no points of intersection. So all of these had a positive, but yes, you do have the negative A scenarios as well. And just a bit of terminology. In the first case, we call the line there, the f of x, we'll call it a secant. So f of x here is a secant to the parabola. Secant means it meets at 2 points. And in the second case, when we have one solution, f of x is a tangent. Okay, when it means just at one point with the parabola. Yeah. There's no name, no. Okay, no special name. So in the first one, I'm still going to label this. I don't know what the expressions are, but let's say g of x for the quadratic, g of x for the quadratic, and g of x here. Okay. So the way we solve these linear quadratic systems are very similar to the substitution method. So if I have, for example, an f of x and the g of x, I already have the expressions for y. So there's not a lot of work involved in just isolating for the y coordinates, right? So in the first one, all I would have to say is if they were to intersect, if the f of x intersects g of x, then you know that f of x has to be equal to g of x, right? At whatever point of intersection there might be, okay? So you always start by just setting this up for yourself. So one of them will be linear, one will be quadratic, but I know they share the y coordinates there, okay? So that's the main condition you want to remember. Yep.
What is secant and tangent?
So secant means this function, the linear function, goes through the parabola at 2 points. And tangent means it goes through the parabola at 1 point. But it's not always about parabolas. It could be a circle, for example. Secant means 2 points, and tangent means 1 point. Okay? And it's always the linear, not the quadratic. So that's why I pointed it at f of x. So the linear in this case. Okay? You can't say that the parabola is secant or linear. It's the linear. Okay, so we have f of x is equal to g of x. But I'm not going to use it in this form. I'm going to use it in an actual equation form. So I'm going to move f of x and g of x to the same side so that I get this. F of x minus g of x is equal to 0. Why do you think that's important? So if you think of this, the f of x, the way we described it up here, f is linear, g of x is quadratic. So let's say I have something like this. It might not be this. You don't have to write it down. So 2x is equal to 3x squared minus 4. Is there any way to solve it by keeping the two sides separate? No. But if I move everything to one side, then I have a quadratic. And I can use probably the discriminant to solve for how many solutions that quadratic has, right? Which will in turn reveal how many solutions the system has. Okay? So that's why we have to turn this one, f of x is g of x, into just one equation, which will be a quadratic usually. Okay? So solving steps, you always just start with f of x is equal f of x minus g of x is 0. That's 1. The 2, solve, maybe say determine delta. Right, the discriminant. And then you just have to decide, assess number of solutions to the linear quadratic system. So assess number of solutions to the linear quadratic system. How do I assess it, though? What do I remember about the discriminant? We did nature of roots 3 lessons ago. Adele and then Rebecca? Yep, okay, so yeah, the expression was our b squared. There's no square root, right?
Oh, sorry, like the...
Yep, okay. But how do we interpret this? So we went with b squared minus 4. Sorry? Yeah, Rebecca? Okay, yep, so I can have 2 solutions. Oh, what just happened? Cannot blame that one on Wi-Fi. Okay, so we have 2 solutions, 1 solution, or no solutions possible. 2 solutions means 2 points of intersection. 1 solution is 1 point of intersection, and here I have none. Okay, but again, if we remember the discriminant, we link that to a negative discriminant being 0 solutions, a 0 discriminant being 1 solution, and a positive being 2 solutions. Once again, this applies not to the quadratic function, it applies to f of x minus g of x, okay? It's the delta for f of x minus g of x is equal to 0, okay? I can predict a few mistakes on the test already. Maybe not. Okay, so we're all good with this? An example, maybe? Okay. Raise your hand if you're still writing. No? Okay. So we have a linear, in this case they're flipped, so f of x isn't always linear, right? So this is a quadratic, g of x is a linear. Okay, what's the first thing I have to do here to figure out the points of intersection? First step. What was the first? F of x minus g of x. Okay, so I have my, I'll still write it out. I know most of you won't after all, but f of x minus g of x is minus x squared plus 6x minus 5. And I'm going to use my brackets here so I don't forget the signs, right? So negative 4x plus 19 is subtracted. So that means I have a negative x squared. The 6x and the positive 4x will give me a 10x, okay? And then I have a negative 5 minus 19. Negative 24. Okay, so I have my equation. What do we do next? Yep, Matilda?
Use the discriminant?
Yep. So it says the discriminant, we have our delta is 10 squared minus what?
Plus 4.
4 times negative 1 times negative 24. Okay, and that will be 10 squared minus, is it 96? Which is a nice value of 4. Okay, now is this greater than 0, equal to 0, or less than 0? Greater than 0. So what do we do with this? I know I have, yes, 2 solutions or 2 points of intersection. We're actually asked for the points of intersection, so what can we do next to figure out the value, maybe of the x-coordinate first, and then we'll see what we can do about the y. Okay, I'm still solving here. So within here, I would go and solve for the x. I can use the quadratic form. I already have the discriminant, right? So the x1 and 2 in there will be negative 10 plus or minus root of 4. I already have that. Yep, I'll just write it anyway. And then 2a is negative 2. So we get a negative 10 minus 2 over 2 and a negative 10 plus 2 over 2. What's the first root there? Negative 6. Okay, and the second one? Oh, minus 2. That's right. Thank you. Okay, so we have, yes, plus 6 and then minus 8. That's a 4. Okay, so I have the two x values for the points of intersection. Where could I go to figure out the y coordinates? Remember, these represent points on both the parabola and the line. So there are two ways I can do this. One is a lot more efficient than the other. Jasper?
Just plug into the linear function.
Into the linear. That's right. So that would be f of x or g of x? G of x. Okay. So a g of x, I'm going to solve for g of 6 and g of 4. You all remember the notation, right? Okay. So g of 4 would be negative 4 times 4 plus 19. That gives me a 3. And 6 would be negative 4 times 6 plus 19. So it's negative 24 plus 19. What do we get there?
Wait. 3 and
24 plus 19.
oh.
Negative 5. So as points, we usually report these as points in coordinate form. So I have 4, 3, and 6, negative 5 are the POIs of f of x and g of x. It's always good to remind yourself what you're working with, especially when you suffer from memory loss, as Neil would say. Yep.
If you can't factor the equation,
What do you mean? If you? Oh, yeah. In terms of solving for the roots, you can use whatever method you want. Yeah. But here, it's usually efficient to go with the quadratic formula because you already have the discriminant, right? But if you do see a different factoring strategy, it's fine. Okay. Do you guys want to work with b independently? Okay. 3 minutes, and then we'll pick it up. So it doesn't matter what order you go in. You can do f minus g or g minus f. Okay.
the one just there to the back.
Yeah. That's right. Yeah. So you can go this route, or you can subtract the other way as well. What did we get for the discriminant? Oh, did you? Okay, so let's see. 2 squared minus 4 times negative 2 times negative 1. 4 minus 8. At this point, I accept you just saying less than 0, and that would be no POIs. Okay. Now, did everybody start this? Is that what you were working on? Yeah. Okay. So in this case, I'm not... Sorry? Okay, I'm given a line, but I'm not given the full equation for the line. I only know the slope. And I know it has a point of intersection with this function here, okay? And I want to figure out the coordinates. So I'm still going to build an equation for the line, but it's not going to be a final equation, okay? So it's, in a way, it's a little bit backwards from working through this here, okay? We're starting with the condition for the discriminant because we know they have one point of intersection, okay? So that automatically tells me the discriminant is what with respect to 0? Equal, less than, greater? Equal, okay? I have 1 point. Does that make sense? Everybody? Okay, so we're on this one. So you can still call these just so you keep track of them. F of x, let's say, is the linear. And I know there I have a slope of 4. How can I write that in equation form? 4x, that's right. And I don't know what the intercept is, so I'm going to leave it as plus b, okay? So I have a general expression, g of x, even though I'm given it as y, I'm going to rewrite it as g of x is 1/2 x squared plus 2x minus 8. Okay, so these are the two givens. Hopefully that's not mistaken for a 6. It's a B, okay? So I have these two. I already wrote down the delta condition there, okay? And actually this one is where it gets tricky. So let's not use B, let's use Q, okay? For the intercept, okay? These are not set in stone, so just use a Q. You'll see why in a bit, because I have a B for the quadratic here, okay? So just for now, leave it as a Q, okay, as a habit. Yeah.
Oh, we
I just, yeah. I just slope of 4, and we don't know the intercept yet. Okay, so it's just a general equation. I know it's a line, it has a slope and an intercept. Okay, so I know the discriminant is 0. Okay, so these three together I can use now. I'm going to go straight to this and figure out what that means in terms of the two expressions, right? So from these two, I get a 1/2 x squared plus 2x minus 8 minus 4x minus q is equal to 0. And I'm not quite at the discriminant stage yet. I know 1/2 x squared minus 2x minus 8 minus q is equal to 0. And this is where you have to be a little bit careful, because you're going to read off your A, B, and C, right? So your A is what? A is 1/2, B is -2, negative, and then C is minus Q, okay? So this is where you want to pay attention, okay? You're going to take all of them. So A is 1/2, B is -2, and C is -8, Q. And now I can go directly and take these two together, right? I know my discriminant is B squared, so delta, I'll just say we're going with both of them. So we have B squared, which is -2, all squared, minus 4 times A, which is 1/2, times the negative I'm going to keep out, and I'm going to factor that to an 8 plus Q. And I know all of that has to equal 0. Yeah?
Could you just move Q over to the other side and have the quadratic equal Q, or is that just...
I don't think you can separate these two because there's a multiplication here, right?
No, but I mean, like, in the step before that, when you were just stating the quadratic, could you not just do that? Or would
Up here?
Yeah.
But, okay, where would you go after that? What are you doing with
Would
that?
you be able to solve the quadratic using the quadratic formula and just have to equal 0? That's what I'm saying.
No, yeah, well, there's no way to solve for it. You can only solve for the roots if all of it is equal to 0. If you move it to the other side, like this here constant, you have an x and an x squared, and there's no way you can separate the two to solve. It's not like in a linear equation. So yeah, you need to have all the terms on one side. Yep. Okay, so we have a 4 minus, here is a 2, and I have these two negatives, which will give me a what? Positive. Okay, so we have a 4 plus, I have a 2 from this, and an 8 plus q. Okay, so if I want the q, what am I going to do next? I could expand, but I noticed there that this is 8 plus q. So I can keep it together. I can move the 4 to the other side and just solve that way, right? So we have 8 plus q is equal to -4 all over 2, which means q is -2 minus 8.
Wait, how do we get 2 out of 4 times 1?
Sorry, where?
How do we get positive 2 out of 4 times 1?
This one? Oh, here?
Yeah.
So that's a 4. This is 4 divided by 2, which is 2.
It's negative.
Yeah, but I have two negatives, right? So that negative is multiplied by that negative. So it gives me a positive. Maybe we should add a bracket here just so.
Are you able to if you're like that? Multiply?
Sorry?
If you're multiplying it by the 2, wouldn't you have to distribute it and move it over? Can you just like take out the entire term?
No, because you have to think of this as one number, 8 plus q, right? So I can keep it together. I move the 4 around, and then I just isolate for 8 plus q. Yeah, you can, because it's protected by that bracket. So that's one number. You can solve for it. But you can, if you're more comfortable with expanding and then regrouping, do whatever you want. It doesn't matter, okay, how you approach this. So q is -10, but what did we want in this question? What was it asking us?
Y-intercept.
Yeah, the y-intercept, right? So the equation, the full equation of that line, which was f of x, we called it. So all you have to do here is say f of x is 4x minus 10, and that's your final answer. You don't necessarily have to write all of these steps down, right? So for this wouldn't be required on a test, but these two lines should be there, okay? And then you can go straight into discriminant and just solve. Is everybody intimidated, or should I give you a minute? Okay, no feedback. Okay, you try example 2 all by yourselves, okay? And then we'll discuss it. I'll just make some notes here. So these were givens, okay? Givens 1, 2, and 3 for the delta, okay? And then all we did was interpret it a little bit, set up the condition for delta, and then solve for the q.